Hi, so today will be the eighth lesson, and then I'll be teaching how to write and use functions in Python. So first, a function is a block of organized code that you can reuse for again and again for the same purpose, and it does the same action multiple times. And it's used so that there's not a lot of repetition in your code. And then Python has some built-in functions like print, but we can also make our own functions, and these are called user-defined functions. So to define a function, you first put the word def, like define. You and then you add your function name after, and then you add parentheses, and then you put your parameters in. So for example, if you were making an add function, your parameters would be like two numbers, like here. And then this is the function name, and then you add the parameters inside. And there can be as many parameters as you want. You just have to separate them with commas. And then in the function, you can do all the actions that you want to perform. You write them like regular code, and then you can return a value. And then, so then yeah, that's how you write a function. And then you also have the option of not returning anything if you want the function to just do something. So this function is like an adding function. And what they did here was they, to write it, you would write define def, and then you would add the function name, calculate, and then the parameters are a and b, and that is the function signature. So then if the user calls calculate something something, then it will run this function. So in here, this is what the function is supposed to do. And then finally, it also returns this value, returns C. So if you want to get the value that you returned in a function, you would put it in a variable. So this is what they did here. You write a variable and you say result equals calculate 3, 5. And then this statement is basically C, which would be 8. So if you run it, this would print result is 8. Yeah. And it also prints an extra 8 because inside this function, there's also a print C part. So then also for calculate 30, 15, it would print 45. So then another another few functions that another few examples that there are in these functions is um print me. This is another function, define print me, and it'll just print a string. And then square returns the square. So to write this function, you add the def first, and then square is the name of the function, and then the parameter is x, which is the number that would be squared, and then you have to add the colon, and then in this function you can write all you want in one line, so it's just returning x times x. And you could also do something else like you write another variable c equals x times x, and you return c. But that's the same thing. This one is just more compact. And then this other function is it took a list in, and then the function returns the first two items of the list. So then this did, you write def again first, and then you write the name of the function first two items, and then you add the parameter, which is the list, and then it returns list, and this returns the first index of the list, and this returns the second index of the list. So then Um, I want, can you guys write a divide function? So it takes two numbers in and it divides the second number from the first number and it returns that. You can say it in chat. Okay, so to write a divide function, um, that one is not exactly how you would do it. Could remember the parameters are separated by commas? Yeah. Yes. Yes. And then could you guys write how you would call this function? For example, with numbers like 2 and 4 and put it store in a variable result? Yes. So to write the divide function, it would be di- let's just call it divide, and then you have a turn A over B, and then um if B was 0, it would return an error. So to fix that, you could do, I'll show. If B is 0, you can write an if and else statement, and what you do is you check if B is 0, then you return like divided 0, and then you can just have the return A over B under it, and then that would fix the issue of dividing by 0. Does that make sense? Because then after this return is called, then it will only go to this statement if B is not 0. So then it'll only divide A by B if B is 0 and return that. Does that make sense? Yeah. Okay, so for another practice, um, can you guys write a function with a that takes a list as an input and then it returns the biggest element in the list? And it's a list of integers. Yeah, the biggest. Oh yeah, there was already a maximum function. But pretend there is no max function, and then can you write the maximum function? Oh yeah, I guess you could do that. I meant without max, but yeah, that works. Like using a for loop. Yeah. You can also do max. I like this one, but to instead of setting max to negative like a bunch of nines, you could just do the first value of A, and then you know you don't have to just set it to a random number, and then it's like uh, I in range for I and this. Then turn back. And then, okay, so moving on to calling a function, we already kind of went over this. It just, to call a function, you have to write, you can do it in two ways. If you want to just do the action, you can call the function and then put the specified parameters in it, again separated by commas. But if you want to initialize that and put it in a variable, then you would do like um you would put a variable and like set that variable equal to the function. So then these are examples with a square function. Then yeah, find max. So that does that all make sense? Okay. So then next moving on to default argument values. So what this means, what we're talking about here is that if any of the parameters in the function are declared with the format like here, argument equals value, then you will have the option of not specifying a value for those arguments when you call the function. And if you, oh yeah, the square doesn't work because what happens in this thing is that it takes like each thing separately, so you have to define it each time. So what I would have to write the square function again, saying like, and then it would work. It's just that you can run the. Okay, so it says you can just run the above cell and then they'll work. But this one didn't work because it was a string. Okay, so then, yeah, moving on. to arguments, then, for example, so going back to the default arguments, if the argument already has a set value, then you don't have to add that argument. So then, for example, in this function, what this function did was it asks if something is it's called ask okay, and then prompt is the only value that a user needs to input. So then retries, if the user sets a retries function, then it would set it to something, the retries would be different. But if the user didn't add any parameter in, the retries would automatically be set to 3. And then for a reminder, it's similar where the user could write their own reminder, but also if they didn't, then this would be the default reminder. So then what this function did was that it ran a while loop and then made a function called, a variable called okay, and it's taking input from the user. So this is the part where in the code there has to be a value put in for prompt. And then if okay is something like y, ye, or yes, then it's true. And then if it's not, then it's false. And then the retries will, if retries is less than 0, then it won't work. And then the retries can be as many, as big as of a number as the user wants. And then if retries is less than 0, then it will leave. And then finally it'll print the reminder. So then if this one works. So for example, here, the user set the value for everything. So then the default values aren't used. So then if I wrote yes, then it would return true. But if I wrote no, retries is now set to 1, so then it would print false. Return false. And then but yeah. So then this one is the prompt. For this function, the prompt was changed to okay to overwrite the file, question mark. And reminder was set to 2. Retries was set to 2, but then no reminder was set. So then the reminder that would be printed would be, it would be what would be printed was please try again. So then, for example, if you wrote, wait, if you wrote, for example, if you wrote this, then it would tell you to try again. If you wrote something that wasn't there, right, ask you to try again, it would ask you to try again. And then it wouldn't work. Yeah, then there'd be a value error, invalid user response. So then here, when this function was called, this is the prompt. This is reminders is set to 2, and then reminder is set to come on only yes or no. It's not please try again anymore. So then an important warning is that the default value is only evaluated once, and this makes a difference when the default is a mutable object, such as a list, dictionary, instances of most classes. So, for example, in this function, the function accumulates the arguments passed in it onto the new cells. So if you ran it, it would print 1, 1, 2, and 1, 2, 3 because the L would just um be the same. It's the same L over like the same L that the L is set to the same array list that is used each time it is called. So then instead of going back after you add 1 to the list, it's not when you call F2, it won't reset it to an empty array. It'll just keep the same list and then it'll add 2 and add 3. So to avoid this, what you have to do is a you have to define a function, and this is the default value of L. So if the user didn't add a list that they wanted to append to, then list would be none. And then if list is none, then this would reset it every time. And then here you can see when you run it, print 1, F1, F2, F3, it'll add the different arrays each time because a new L was made each time. So then, for example, if you wanted to print people's information, you could write a function like, for example, print then when you run this one. Oh yeah. So then here, what this is saying is that order matters when you run when you write the parameters, for example, because it's not specified whether each different parameter is like a string or an integer. When you switch it around, it'll just assume that like 20 is the name. And then when you try to print name plus name, then it'll print this it'll print 20. It thinks 20 is the name and it'll try to print 20 plus the name, and you can't do that because you can't concatenate strings with integers. So then you'll run into an issue. So when you write your functions and you use them, make sure that your parameters are in the right order. So then to fix this, you would have to switch them around. Then, like if you wanted to print something else, then you could do it. So then next is about keyword arguments. So then functions can also be called using keyword arguments in the form of like the keyword argument is equal to a certain value. So for example, in this function, the parameters are voltage, state equals, and these are the keyword arguments. Yeah, these are the optional parameters. State equals astiff, action equals voom, and type equals Norwegian blue. So then if you didn't set a new if you didn't set like add these other parameters, these would be the default values. So then what this function does is this parent wouldn't, and then it does the action, and then end is equal to something. If you, and this prints, the next after that it would print if you put blank volts through it, and then it just calls these the different functions that there are. The voltage will keep growing. So then, for example, this is the argument for voltage, but when you called parrot, this is just what it does. But then next, if you, instead of using this as a parameter and instead doing a keyword argument of voltage equals 1,000, then you're resetting voltage to be 1,000. Before it was, because if you called parrot 1,000 before, then voltage would have added one, and it should have printed 1,001 if you called it. But then instead they set voltage to be equal to 1,000, so then it like resets. So then here the two keyword arguments are voltage are equal to 1,000,000 and action is equal to boom. So then when they print it here, what happens is that this this is the argument that's called, this is action, and then this is voltage. And then the next one that's called is the keyword arguments. They're able to, the next important thing about keyword arguments is that you can switch the order of keyword arguments and they won't result in an error, unlike what happened before when we printed this. So to like fix this now, you could have done age equals 20. Gender, height, and when you run it, it works. So that's what keyword arguments are. You can set, like you can use the parameters more easily and it's more like usable. So then if you did this, they if you did this then voltage would be set to 1,000,000 and then bereft of life would be set to this state would be set to that and action would be set to jump. And then the default type would be Norwegian blue again. So that's what happens when you don't use the keyword arguments. They will just go with whatever position that they were originally in. They'll just match up. Like the first one will go with the first one. 1,000,000 will go with voltage. Breath of life will go to state. And jump will go with action. And then when you call pair like this, then there's one positional argument and one keyword argument, and 1,000 will be set to voltage, and state will be set to pushing up the daisies. But instead, if you said like action equals this, then action would be set to it. And even though this is the second position when you called it, it would be set to the third one here. So can you guys use send how you would call parrot if you had two positional arguments? So just two regular arguments and no keyword. And then also run to write an example of how you would do it with two keyword arguments that are out of order. Yeah. So the example in the chat works, yes. If you just set parrot to be, you called, if you wanted to add two positional arguments, it could be parrot like 1,000,000, and then the new action could be like, instead of eating beans, it could also be like eating seeds. And here voltage, it would just be in the order that it is. So voltage would be set to 1,000,000 and state would be set to eating seeds. But if you use keyword, then you don't have to do it in order. And you could set action or type to be like, to be, and then you separate everything with commas again. And then you set state to be, um, or something. So then here, instead of going in the order, if you went in the order, then voltage should be set to boom and state should be set to sitting. But because we use the keyword arguments, um, action is set to boom and state is set to seating. So this one is if there were two positional arguments, and this one is if there were two keyword arguments. Okay. And these are like invalid cells, for example, because um for keyword arguments, you at least have to set, like for example, in this function, whether you use keyword function arguments or positional arguments, you always have to set voltage to be equal to something because voltage doesn't already have a default value. So this function would fail. And another cell that would fail would be like this one, because you can't use non-keyword arguments after a keyword argument because the order of the parameters would probably be mixed up and hard for the computer to determine. So even though if you wrote this, you think the state should be set to dead after you set voltage, it doesn't work like that. So every time you use a keyword argument, make sure that all the arguments following that keyword argument are all also keyword arguments. And then, for example, this one doesn't work because it is two values that are trying to be used for the same argument. Because again, the first argument, this is a positional argument, and the positional argument goes with the order of the parameters, and the first in the parameters is voltage. So then voltage would be set to this. But then if you use the keyword argument voltage equals something else, then it's a duplicate value for the same argument. And then this one, you have to make sure all your actors are correct, and this one would also fail because voltage didn't have a value set for it. So make sure that your keyword arguments follow the positional arguments. Make sure that all the arguments that you need to set for sure are being set, and make sure that you use the correct keyword arguments that match. Yeah. So next is talking about variable length argument list. So basically what this says is that Python can allow you to declare two special arguments which allow you to create argument arbitrary length argument lists. This means that each time you call a function, you can specify any number of arguments above the certain number. So for example, here, even though you would like a print function should only be able to like what happened was that they defined the print function to have like maybe first, second, and then the asterisk is used for the remaining numbers, and then they just printed everything. But if you do this, for example, it won't print the first and second. So if you wanted to also print the first and second, you would have to add a print first, print second. So just keep that in mind with your arguments, because usually with these functions, you're trying to do something, maybe the same thing to every single argument. And keep that in mind that whenever you do that, you have to make sure that it works for all of the arguments. So that's what happens when you use with one asterisk. But if you use two asterisks, then it will be bound to a dictionary containing any keyword arguments in the actual parameters which don't correspond to any formal parameters. So what this means is that it will be separated. So for example, what happened here was that it has the max length that in this make dictionary function, what happened was that they defined a function called make dictionary, and the parameters were max length equals something, and then they added the two asterisks, which means that it is bound to a dictionary containing any key arguments which don't correspond to any formal parameters. So then what this function is doing is it makes a dictionary, and then the key is the key along with entries key, or if you do like I in range this. So basically what this is doing is it takes the value in like key 1 equals 5, and then this when they make the dictionary, this turns into key, and then the value of the key is the value following the equal sign. And that's put in entries key. And then it goes for if that width, and then as long as it's less than max length, then you can put the values in the dictionary. So then when you make the dictionary, yes, this is what it returns. And it doesn't return key 3 because it's less than the max length. So then that's how that works. So basically with two asterisks, it's different than the one asterisk because it is like a dictionary. It works like a dictionary. So for example, in this next example, this next function is called cheese shop, and it takes in the first parameter is kind, and then it has the arguments, which is one asterisk, which means it's just one value. And then it has the two asterisks with the keywords, which means it's like a dictionary. So then first it will print, do you have any, and then the kind, and then this. And then next it'll print, I'm sorry, we're out of the kind. And then it does for argument. In arguments, it'll print each thing that the user inputs into the function, the parameters for arguments. And then it'll print 40 dashes. And then it will add the keys. It'll make a bunch of keys, and this just sorts all the different keys. So for example, if it was like key 1 equals this, key 2 equals this, it just sorts key 1, key 2, and key 3. It ignores the 5, 7, and 9. And then for this is looking through the keys, so this would be looking through the values of 5, 7, and 9. So for KW in keys, then it'll print KW and then keywords KW. So if you run this, what this is saying, so here, these two that are printed comes from this, and then it prints these two because these two are the two that go with along with arguments. It's very runny, sir. It's very, very, very runny, sir. These two are the arguments, and you can tell the difference between the arguments and the keywords because the keywords kind of look like what the keyword arguments from before, and they have like something equals something else. But the arguments are only one like straight value. And then next after that, it prints like these three, and that comes from these three, and then that corresponds with this part of the code. And then notice how they're in alphabetical order because here they sorted keywords dot keys, which basically means they sorted these three parts. So then when they print it, it'll be in alphabetical order of client, comes before shopkeeper, and then it comes before sketch. So does anyone have any questions about the cheese shop function? Oh, okay. So then moving on, you can also unpack argument lists, which basically means that when arguments are in a list but need to be unpacked for a function call. Um, I'm confused. Where did the syntax error you're talking about comes from? I think that the syntax is fine here because when you run it, it works. Yeah. Okay, yeah. So moving on to, yeah, you forgot a comp. Okay. Unpacking argument lists. You can unpack argument lists by, you can separate the arguments by adding the asterisk. So for example, the two ways of calling range 3 comma 6 is you could just call it like this, but you could also, because sometimes when you're like coding, you want to add to a list and then call like a function with that list, and it'd be very inconvenient to have to like have a situation for like each length of the list. So what you can do here is you can also add a asterisk and then add the arguments, and then like you add the list, and that will just unpack the list and treat them as if they were separate arguments too, like separate parameters. So you can also do this with the you can also do this with the asterisk, the double asterisk operator. So basically this is a dictionary with all of the different values, like voltage is supposed to be something, state is supposed to be this, and then action is supposed to be this. And when you add two asterisks, it treats it as a dictionary of each value. So it would know that voltage is 4 million, state is this, action is this, and it would just run the function. Like running this function is the same as running parrot volt volts 1 million. And notice when you run these two, it does the same. It runs the same exact thing. So this is the same thing as calling this. And when you run the dictionary, it's the same thing, but it can be more convenient sometimes. So next, you can also attach documentation to a function by including a string at the beginning to say what it does. And you should do this because it's important that you to stay organized in your code and to do when you collaborate with others, it's really hard to know what a function does right away. But if there was an explanation at the beginning of the function saying what the function is, it's much more convenient for everyone. So to like define the functionality, you need to add and you should add like a string at the beginning with what it says. So then, and this will be the documentation. And if you if you want to know what the documentation is to run it, you can run, you can use the help function that's already in Python. And then you put the function name into the help function. And then it will tell you, it'll just print what you wrote in the documentation in the string at the beginning of the function. And you can also do print if true, call it with the question mark, and then you can see on the side it will also it'll print the documentation. Another way to find the documentation is to print if true dot underscore 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 doc underscore underscore underscore. So with this, there's like many ways to print the documentation that you wrote. Okay, so next we're talking about objects. So Python is like everything is an object, including functions, which means you can assign them to variables, which we already talked before, and use them as arguments to other functions and return them from functions. So basically, what this part is saying is that we define these two pretty self-explanatory functions, right? But then the third function, it just runs the function that is in the parameter. So if you do run something answer 1, it's the same thing. Run something answer 2, same thing as just running answer 1, answer 2. And if you run it, it's the same thing. So what this is saying is basically that functions can be used as parameters. This other example also is you can take the function as the argument. It's very convenient because then you don't have to like Otherwise, you might have to add a bunch of if statements with like if the function is add and then return. But instead, you could take the function as a parameter and then the other two parameters and then just run the function. And as you can see here, it works. And then also, you can put a function in a function. So for example, here, they make it define an exponent factory. And then inside that, they defined another exponent function, and that returns this parameter to this parameter's power. And it returns that too. So then this function, inside this function, it'll return a to the power of 10, I mean to the power of n, and then exponent is a function again. So then when you add that, then it'll return that value. If you run this, it'll print that. And then basically what this did was that we made a new function called square. Square equals exponent factory 2. So then it defined a new function that when you return that, it will make that function. And you can see that here. The type is called square. Like when they unprinted type square, it returned function. And then if you used it, printed like square 3, it would return 9. And you can also, you don't have to like go through all that and generate the function, then do it. If you wanted to do 3 to the power of 2, you could also, this is a function. So then this function has another parameter called 3. So basically the 2 would be n, the 3 is a. So then when you run it, also returns 9. So then this is basically just making another square function, calling it, but it's compacted to one line. So then if you put everything together here, you can make a timer. So if they return, if you import clock and then you add that, you can define a timer. I think it worked above. Anyways, you can define a timer and then inside you can make another function factory and then define this when you put everything together. This is as many arguments as you want. And then it'll make a new timer with a new clock. And then it will call this function with f, this new function with f, and then with all the arguments, and it'll just return the clock and return this new function. So then when you did that, it should return this. So then yes. Okay, that will be all for today's class. Thank you for coming.